Well, hello there. I'm starting a little bit early today, and probably will be on all Wednesdays because of my new schedule. And this is stream number 45, and I'm working on making my own web server in C++. And I have a link to the OneNote notebook where I keep all my notes here below. If you're watching this on YouTube, you try going to my Twitch stream, and you'll see the link there. So we have a live web server up and running, and we can show you. I can show you that really quick. It doesn't do much. Go to rimu.com/static/index. As long as it's running. Not be running. Hold on. Just a moment. There we go. So we can connect to what I have called a chat room, but it's really right now just a little demonstration of the server and the interactive nature of WebSockets. And we have a timer that runs, and every, I don't know, 30 to 40 seconds, it posts a math question, like there we go. And if I do my math correctly and answer correctly, I get a point. And anyone can log in, pick from one of these predetermined nicknames, or just lurk like that. If you're lurking, though, you can't make any guesses. Anyway, it's up and running if you want to check it out. And today, I'm working on a couple things. So, reason why right now, a few minutes ago, it was not connecting and I had to go my server and restart it is I believe that it's caused by this deadlock that can happen between two different threads in my server. So I'm going to go in there and fix that. And then I'm going to work some more on the idea of IP address blacklisting of clients who issue bad requests or too many requests. Right now, we just put in a very draconian check where if there's any kind of bad connection, the IP address of the client will just be blacklisted as long as the server remains running. We want to change that so that there's an initial blacklist period. During that, we'll do what we're doing now, which is close any incoming connection. But after a certain amount of time, we'll put it on probation where we'll accept connections again. And a good request, not too frequent, will remove the IP address from probation after a probationary period. However, if there's any more violations, so the two that I could think of are a bad request or too many requests, then it goes back onto the blacklist with a double the previous period. The idea is that if we get probed or hacking attempts, we will mitigate that by at first timing them out, and then eventually the blacklist period will become so huge that they'll never get through. So we're going to work on that today. And I had taken some notes about this deadlock first. I saw it happen in the last stream. So what's happening right now is in this order. A connections processor thread grabs the processing mutex. Then the timer thread in the server grabs the server mutex and tries to grab the connections processor mutex, it should say, in order to close the connection. So it'll be waiting for the connection processor to release that mutex. And then the third step is the connection processor is still holding that mutex. It tries to grab the server's mutex in the server's broken delegate in order to react to the connection being broken. So that deadlocks because now timer thread is waiting on connection thread, the connections processing mutex, and connection processing thread is waiting to grab the server mutex. So they're both waiting for each other. And that's the definition of a deadlock. I think the way I want to solve this is to prevent this kind of thing from happening, trying to get a connections processor mutex while holding the server mutex. So in other words, we want the processor thread mutex, processing mutex to be higher order mutex. So you have to grab that one first, and then you can grab the server mutex, but not the other way around. So I'm going to go and look at the server right now for the timer thread. Here's the timer thread, and here's where it grabs the server mutex. What's happening is it gets down here into issue response when a connection times out. An issue response calls either the send data or this break. In either case, if you look at those, like let's look at send data, for example. Send data calls send message. Send message calls an internal send message. That one gets the processing lock. So that's the problem, is we don't want to attempt that while holding the server mutex. I think what we can do is pretty simply, if I do this right. Yeah, so this is the last time we'll need the connection state. We can simply unlock the mutex, issue the response, and then relock it again. Like this. So while the server mutex is unlocked, this can now block waiting for the processor mutex without causing the processor thread to block waiting on the server mutex, because it'll be unlocked now. We just have to make sure that we're not using any, or depending on any state that might have changed between this unlock and then the subsequent relock. I think we're fine because, oh wait a minute, no we're not. This connections list might be changed. Oh no, we're already copying it. Yeah, so we're making a copy of it, probably intentionally, because I expected it might change during the loop. Right, so we should be good. Connections being the thing that might change. No, active connections being the thing that might change. So we make a copy of it so that won't change. And then after we grab the lock, it will loop back, continue, right? I think we're good. It's going to be difficult to know that we've solved this for good unless we see the deadlock again. And probably what I should do, my notebook, is consider refactoring server and possibly network connection as well to not require mutexes. Or just not require them as much. So I have an idea to use lockless data structures for that. And I can go into more detail at some point later, but we'll just move on for now. I just want to make sure that this does not break any of my unit tests. Alright, so no tests are broken. Let me do a W stage followed by a W serve to start up a local copy of our server, and then I will go to localhost 8080 static. Actually, I'm not sure where this goes at this point. Yeah, okay, this is on my local server. It doesn't go to the chat room. It just goes to a test page. So that we can use to hit the server a few times to make sure it doesn't break. So I think we're good. That was in HTTP. Let me adjust my mic. You might hear a little bit of noise. Okay. We're going to check that change in. So server. Don't hold the server mutex when, oh, we're going to make this the main body. Fix deadlock between the timer thread and network connection processor threads. That's a little bit too long, so I need to abbreviate this. I'll just say fix a deadlock. Don't hold the server mutex when calling network connection methods unless it's already in the context of a delegate given to the same network connection. So this is sort of an exception that I allow because we designed in network connection to be reentrant. So in other words, if we look at system abstractions source, we look at like network connection .cpp, I think. No. I'm looking. No, it must be in the Windows specific stuff. It's where this processing mutex is declared. Yeah, we declare it as a recursive mutex. That allows us to reenter and lock the mutex we already locked. As long as we already have it locked, we can lock it again. That simplifies things a little bit. If it wasn't recursive, we would have to have some kind of asynchronicity in the methods to prevent to allow reentrancy, which I probably want to move to and then be able to get rid of that mutex entirely. But I'm gonna opt to do that in a later refactoring stage, I think. All right, so we're hopefully done and have solved this part. Let's move on to the blacklisting stuff again. So the test for that was in server tests here. So we have a test, bad request results in ban. And let's go over this. So we first set up a web server. We set up a mock connection. We issue a bad request. So that's obviously a bad HTTP request. We expect to get back a response. And it'll be a 400 response, which means bad request. And then we'll expect a graceful disconnection from the server. So next we'll start a second mock connection, and this will be from the same, it'll appear to come from the same address. And when we issue another bad request, we'll expect, this basically says the connection is never really fully connected. In other words, the connection is just rejected. And we expect that it's broken abruptly. In other words, that we're banned. I think what we want to do is change this, right? Because we have this done, but we don't have this concept of a probation period where it'll be accepted again. And I think what we should do is further bad requests or too many requests resets the probation period. So in other words, it could continue indefinitely until we get a good request or and a backing off of the too many requests. I don't think we'll double the blacklisting period though. Hold on, maybe we do want to do that. Yeah, I guess we do. So it's sort of built into this one. Complete sentences. So yeah, we do want to return. So we're gonna have 3 states basically for a given IP address. It's either unknown, or in other words, it's trusted, initial trust, right? And then on probation, where we could accept the connection, but if we get a bad one, we will double the blacklist period, and then a blacklist state, right? Right now we only have 2 states. It's either banned or not. I suppose what we'll do is duplicate that test, and we'll say that to test that it's on probation, right? We'll have it wait until the initial blacklist period is expired, and we're on probation, and then we'll try a good request, and that should actually come through again. Right? So good request while on probation. Good request accepted while on probation. So same kind of thing, set up the server, set up not connection, issue bad request. We don't need to repeat same expectations here because the other test does that. Here we will advance time until the client is on probation. Probation. Which means we have to kind of set a probationary period, right? Well, not probation period. It's the initial blacklist period. So initial blacklist period. So it doesn't really matter what we set it to, so I'll just set it to 1 second. And we'll just advance the time, so that's time, is it timekeeper? I don't remember. Yeah, okay, so it's when we need it, we do this. Oh, did the wrong thing. We keep a reference to it, like so. And then we can use it. Although I guess I could have reached into depths since we still have that around, but this is easier to read. So current time equals, then we'll advance it to like 1.5. Then I guess actually right here we need to release the connection. Right, then advance the time, then start a new connection. Issue a good request. And expect some response. It doesn't matter what we get, as long as we get something. So let us take this and copy it. But we'll make the request a good one. So something like get slash http 1.1, right? And then post example.com. I think that's the minimal request we can have, right? A lot of my other tests, you have other stuff like, well, that's pretty minimal. It's not, it's actually not even complete. Okay. Yeah. Yeah, we don't need to have this length anymore because we're not putting any null characters in mid-string. Alright, so we will expect a response, and it doesn't really matter what we get. We will expect that it's not, the connection is not broken. Sounds good, right? Alright. This is server. No, HTTP test debug HTTP test. Right, so it's actually crashing. Probabian? I misspelled it. Probation. So, because it's throwing an exception, It says it here, C++ exemption, bad function call. Let's follow it and see what's going on. Actually, I already know what's happening. It's we should need to put in a test for this, a check. It's this. This check needs to be done. We expect that when the connection comes in again after it's put on probation, it should actually get connected to the server, which is indicated by this data receipt delegate being set. Okay. Okay, I didn't expect that to happen. Oh no, I did. Sorry. This we'll say assert, because if we fail that check, we could actually crash when we try to call it there. Okay, there we go. We're not crashing, but the expectation's not passing. So, of course it's not passing. I should have said before, we're doing test-driven development, so we're changing or adding use cases in our test framework first. And we expect them to fail because we haven't written the code to do the right thing for the use case. So after we verify the test is failing like it should, then we go change the code to add the feature or make the change or whatever to get the test to pass. Let's go do that. So right now we have banned peers, right? And whenever we get a request that causes us to respond with a bad request response, we're going to close them and then add them to this banned peers, and that banned peers is checked on a new connection here, so that if the sender or the client of the connection has the same, it has an address that's listed in banned peers, then we just disconnect them right away and we ignore them. I think we'll keep banned peers, but we're going to change it slightly because I want to have times in here, right? Let's make it a map of string to I don't know, what do we want to call it? Probation record? Criminal record? The criminal record. Okay. Why not, right? So, let's see. Where would we define this structure? I suppose we'll add it after connection state. Criminal record. Whoa. Didn't mean to make the font size bigger. What's font size? I'll stick to 146%. Okay. So, this holds information about a client, a client or potential client of the web of these. I don't like breaking. Oops. I don't like putting a dangling the for some reason. This holds information about client or potential client of the web server, which, well, trying to word this nicely. I'm not going to say of the web server. This holds information about a client or potential client which has made a bad request, too many requests, or for some other reason has should be ignored or potentially ignored. Depends on if they're on probation or not. So we're using a map, so the key is already the address. So what do we need to know? Time, right? So double. Okay, what do we say? I need to know the blacklist period. Or the ban, we'll call it ban. Ban period. And we need to know when it started. So ban start. And I guess what we'll do is, yeah, well, I think that's all we really need. This is the number of seconds that the client will be ignored. Starting, counting from the moment the ban was imposed. And this is a sampling of the time according to the server's timekeeper when this client was last banned. So let's just initialize them to something sane. Default ban period and 0. So let's define default ban period. Okay, const expr double default ban period. I don't know. Something like 60 seconds. Should we say seconds? I guess so. Alright. This is the default number of seconds for which a client should be banned in response to sending a bad request or too many requests. Okay. And then didn't we define a configuration item? Let's make that ban period. So we'll need to catch this. So here's where we can set configuration items. So let's add one. If key equals initial ban period. And let's copy from one of these that interprets a floating point value. The new initial ban period. We'll call this initial ban period and then new initial ban period. Initial ban period. Ban period. Right, and then let's put it near one of the other times that we have here. Like here. Default ban period seconds. This is the amount of time a client should be initially banned in response to a bad request or too many requests. All right. I see a syntax error somewhere. Ah, right. So, yes. So we're going to need to change our behavior here, right? How do we want to minimally pass our unit test. What does our unit test expect right now? So we can say auto ban equals banned peers, and then just look up the address, right? That creates the record if it's not already in there. So then we can say the ban period equals the initial ban period, and then ban start is, and here we need to get the timekeeper. this guy, and ask him what the current time is. All right. Now we need to lift the ban. Actually, we can test it now and it will still not pass, correct? But it should build. Right. So to make it pass, a new connection, we need to be a little bit more liberal. So if they're in the list, we need to check. So see if they should be on probation. So now is the timekeeper get current time. And we'll just say if now is greater than or equal to banned peers entry second dot ban start plus then this again. Actually, I'm gonna make this a little bit easier to do. So it's const auto ban equals that, and then I can just say ban dot ban start. Actually, can I just abbreviate that and say period? No. Technically, it's not a ban, it's a criminal record. In fact, I'm going to say criminal record. Just sounds cool. Ban period. Then we will allow it to be lifted. Otherwise, we'll continue to, not only continue to ban them, actually, or we'll make a test for it, but we should renew the ban, right, and double it. So if enough time has passed, what we'll do is we'll let it continue. We'll lift the ban. We'll just say banned peers dot erase banned peers entry, and then let it continue. Okay. So now we're passing our test. Let's now make let's actually, I'm gonna go back to my notes here. So we have the initial blacklist period. We did check, we still test that. We're testing this. Right now we're not doing this though. We're right now we're removing them from we're removing their criminal record right away on even if they sent a bad request. So I think what we need to do is just instead of doing this ban here, we'll only do it if we end up getting a good connection. So let's make a test for that. So we'll just duplicate this test. And we'll say bad request while on probation extends ban. So how do we test that? I think what we'll do is if we know the initial ban is a second, we send a bad one, then we advance it and we send another bad one. And then we should expect that if we sent a good one, another second later, it will still be banned. We'll have to, yeah, so something like this. Issue bad request again and expect why do I say same response here? Oh, some response. Expect to be banned again. Well, how do I say this? Yeah, well, actually, we don't even need to test. We'll just issue it again. So we don't need to do that. We don't need to parse the response. We can still expect it to be broken, correct? And broken gracefully. So we can clear the connection again. Null pointer. We do that the first one? Yeah, okay. Well, let me think about this. Yes. So we advance time again until the client, until advance time one more initial ban period. We'll issue a good request. Actually, we'll expect, yeah. We'll expect to continue to be banned. Connect a third time, but expect to be banned. Expect to be still banned. Expect it's to be still banned, right? Not to still be banned. So that is this thing. But we assert or expect true. And then finally, advance time, one more initial ban period, connect a fourth time, and expect this time to be on probation. Or, well, really, connect a fourth time and expect this time to succeed. And do we need to do an issue a good request? I suppose so. Oh, I didn't advance it correctly, did I? So 2. Oh, that's 2. Actually, I'm going to go to 4. Because it should reset it, so now it's 2 seconds past 1.5 or 3.5. So that will be comfortably beyond probation or beyond the ban time. This should fail. Right, so we're not being banned after the second bad request. So we need to implement that. Yes. Yeah, so we don't want to erase it quite yet. This just handles the ban, but we need to do this again, basically, if the connection, if the request is bad. So where is that exactly? Data received here. So where we normally would ban them. Where is that? Oh, I think it was an issue response actually. Yeah, here it is. So, okay. We need to handle this a little bit differently. So if they're not already banned, then we ban them. Otherwise, we're going to extend their ban. And let's see. It's this instead of that. So I forgot to silence my phone. Okay, and then we're gonna move. Let's move the now to here. And we'll just say the band starts. Actually, the band always starts now. Okay, it's like this, right? So if they're not in the list, then add them. Set the period to be the initial period and start now. Otherwise, we're still going to extend the ban. I can't put that outside the if though, because it's a different variable. We're getting it in different ways. But still, what we want to do is double the ban time every time. And do we need to do this check? I suppose we do. It's not ban start plus ban period. It's that plus the probation period, right? So while they're on probation, we'll double their ban period. But if they get out of probation, we should sort of expunge their record, I think. We'll just do that by resetting the ban period to the initial ban period. Well, let's keep it like this for now, and then we'll make a test. We'll make a test for the getting past the probation period. Does that work? Yeah. Okay. So we're not actually removing their criminal record though. So that'll be the third test. The third test will be bad request after probation resets ban. So set up server, start connection, issue a couple bad requests to, well, it doesn't really matter. We just issue a bad request. Advance the time the client is past probation. Past the ban and probation periods, right? So we'll also want to set that probation period. We'll set it to also 1 second there so that we can say it's, so if we go to 2.5 seconds, it should be off probation at that point. Actually, I need to send a couple bad requests in order to double initial ban time. Right, so we issue a bad request, then advance the time and send it again. So it'll be on probation at 1.5 seconds. So we will send it again. Okay. So it should be off of probation at 3.5, I believe. To 1.5, it'll be 2. No, that's not quite right. It'll have to go to 5. So from 1.5 to 3.5, it'll be banned. 3.5 to 4.5, I can just say 5. It'll be on probation, but when we get to 5, it'll be off probation. So we'll say, let me combine these two. So we'll issue another bad connection. issue a third bad request. Hey there, Rally Monkey. Yeah, I started early today. I had to adjust my schedule for today because I have to do something at 3. So I need to be done way before 3. 10, transport connection delegate. We don't need to repeat this. I should assert that it's not equal. Assert that. Okay, this is expect. Assert because we're gonna actually call it. Latency is down to 5 seconds. It's been a little bit better. I don't know why. So let's see. Issue a third bound request. Right, connect. Assert that we get a connection. We send it. We don't need to test that. It will fail. I guess we can do this. So it'll be this last one. Hold on. Advance time, one more initial ban period. So let's say 6.5. So connect a fourth time, but expect to not be banned. In other words, the ban period got reset because our criminal record got removed. So this will be expect false, assert false really. And issue a good request, expect some response. There we go. So this will fail because, well, it's not even going to compile, is it? Yeah. Because of the typo. This should fail because our criminal record isn't being removed. Right. So after probation, it should reset our ban, but it's not. So we're still being banned even though it's more than a second has elapsed since that third bad request. Even though we let enough time elapse to get off of probation. So let's fix that. I think what we would want to do if it's an OK request, we should again search. And if they have a criminal record, we should check. Let's move this now up to here. So we'll say if, well, let's get a criminal record reference. And that can be const, I believe. So if criminal record dot, if now is greater than equal to criminal record dot ban start plus criminal record dot ban period and plus the probation period, which we haven't defined yet, then we will expunge them. Their criminal record, I mean. So banned peers dot erase banned peers entry, right? Or do we only want to do this on a good request? Yeah, okay, so I need to move this a little bit. We kind of want to do it regardless, so expunge their record. Well, which means I don't really want to do it here, do I? Yeah, we want to do it when they connect. So right, we ban them, but else if this guy and we'll unban them permanently. So we need to define this, and our test is setting this initial ban period. So we need to have another configuration item called probation period. Probation period. And we'll put it near initial ban period. Default probation period seconds. This is the amount of time required after a client's ban has been lifted before the client's ban period will be reset. So if they do something bannable during probation, the ban period won't be reset, it'll just be doubled again. So let's see, yes, I need to define that. So after they've been unbanned, how long do we want to keep them on probation? A fixed amount of time? Does it even really matter? I could just set it to 0. I don't know. Maybe they have to prove themselves to be good. Let's just make it 60. Make it a minute. This is the default number of seconds after a client's ban is lifted before client's ban period will be reset. Alright, let's just try that. Now is undefined. Oh, I did move that, didn't I? Okay. Const auto now equals timekeeper get current time. Yeah, I was thinking the probation period, maybe it should be equal to the ban period though. Like if they continued to probe us and we ended up banning them for like a day, is it okay to like after a day to like only keep them on probation for 60 seconds and then trust them again? I don't know. Yeah, criminal, I like that. I do like that name as well. Alright. Cool. So I think that does it. So we have, I'm calling it a ban period. So we have a ban period, and then we have a probation period, and after that, it's like it never happened. And if while you're banned, you try to connect, you're not allowed. You can connect while you're on probation, but if you do something bad again, you're banned for a doubling of the amount of time. We don't have this concept of too many requests yet, though. So we should define that. So copy the last test, and we'll say too many requests results in ban. Is there ever a point where they're permanently banned? No. It'll just keep doubling. It's called exponential back off. So eventually it'll just be like in the order of days, weeks, years, and it's effectively permanent at that point. I guess I don't want to permanently ban an IP address because IP addresses these days are pretty ephemeral. Especially if it's from an attacker. They'll usually use an IP address that it's different every time they attack. So you kind of just want to like give them some chances. It could be corrupt packet or something. So, in fact, 60 seconds is sort of a long initial ban time. We might make that less. Might make this less so that, like, if there's some data corruption, then the worst it can be is you can't connect for maybe a few seconds. Not that attackers could spoof their IP, it's more that they could just use an IP that's in some kind of general pool. Like they might use an Amazon Web Services, or they might use a VPN where the IP address is in a pool that it could be anyone, and it could be someone else the next day. It's kind of like a port number. You don't know. There's no permanent allocation or identity tied to them necessarily. Okay, so too many requests. So let's define what too many requests will be. Too many. We'll make a threshold. What do we want to call it? Too many requests threshold. We'll make it in terms of requests per second. So what's a reasonable number of requests per second? Maybe 10? Well, we'll make that the default, but for our test, we'll make 2. Too many. So we'll issue issue 2 good requests, but too quickly. So where's my good request example? Here it is. All right. So I want to actually wait. Oh, it's going to be synchronous, right? So too quickly and expect to be banned. Yeah, actually, we don't even really care about the response. We'll just send it twice. And then to expect a ban is to... Oh, hold on. I need to reset the connection here. So this will be... Actually, we won't even send it. We'll expect it to be true right away. And then we will, advance time. Client is past the ban period. So 1.5 seconds. And then issue a third. Connect a third time and expect to no longer be banned. I can never remember in English. Is it bad to split to and be? Is it better to say to be no longer banned? I think that's right. Okay, so yes. Assert false. And then here's where we expect this. Right. Too many connections. Yes. Too many variables called connection. All right. Okay. It's still too warm, isn't it? It's like 77 degrees. It's still too warm. So we expected to be banned, but we weren't banned, right? Because we haven't implemented the ban thing yet. Let's do that. We need this too many request threshold to be added. Set configuration item, right? We have a lot of configuration items. So it's gonna be an account like this. New too many request threshold. Is to no longer be banned versus to be no longer banned? Yeah, that's what I was asking. And that goes there, and this goes there, and this is too many request threshold. I think you don't want to split, was it calling split infinitives? Or is this going to become a looking up English stream? Maybe. Split infinitive to be. Thought we were told never to split the infinitive. Sought to introduce a prescriptive rule against the split infinitive. Oh, modern English usage guides have dropped the objection to it. So what does that mean, modern English? Am I so old that, like, I remember before it was dropped? Huh. Alright, well, I guess I won't worry about it. Split my infinitives. Oldie English, yeah. Okay. Too many requests threshold. We need to define that. Default. Too many requests threshold. Actually, I'm going to make this a double now that I think about it. Because it's going to be a ratio. This is the threshold in requests per second. Actually, it should be what? Yeah, it's requests, not connections. This is the threshold in requests per second. So we need to have really two tests. We need to have a test where same connection exceeds the threshold, and it should get a special error saying like too many requests, and like then after that it get banned. This is the threshold in requests per second, after which a client will be banned. So yeah, I really wanted a double, and I left there. I think it should I think 10 per second is probably reasonable. After that, it's a little bit excessive, right? And we can configure it. I was thinking 10 because a web app will have at least 3 files that are loaded in quick succession, right? Your HTML, your JavaScript, and your CSS. And then suppose you add a couple more for like the fav icon and maybe another index. So you kind of want to allow like up to a half dozen requests right away, like within the first 100 milliseconds. But if you get like more than 10 per second, I think you're being hammered by a probe, right? Another threshold we might consider is bytes per second. Maybe. I don't know though. Okay, this is the default threshold in requests per second, above which a client will be banned. Banned. Okay, so how do we measure this? I think what we'll do is we'll have what's called a sliding window. So let's, hold on, this should build now. We will have a sliding window. Part of the connection state, I think we'll put it there. So we will have, what's here? Okay, it's just a function. So we'll have a struct window. This is used to compute a running average of some metric over time. So the concept is that we would put in deltas, like the difference in time between two requests in a sequence, and do we even need to do that? I know. What we'll do is we'll put in the times that the timekeeper says into the window for a client, and then as we we'll purge things from the window if they're older than the threshold, and if just the number of things in the window gets past the limit, then we've exceeded it, right? So what we will have some properties, right? Actually, let's make it a class. So methods, properties. Properties. These are the data points added to the window. Really, I'm thinking about making a specialized window though. Do I even need a class actually? It's not going to compute an average, really. Yeah, I don't think. Actually, I'm going to back off from doing this data structure. All we really need is a DQ. So something like this: standard DQ. Yeah, we have DQ of doubles. Last request times. These are the last. These are samples of the timekeeper at each point when the, actually it can't be part of the connection state, can it? It's got to go between connections. So it means when it's got to be part of a criminal record, which maybe I really should now. It's no longer a criminal record. I hate to give it up the name because it's such a cool name, but I think we need to rename it. These are samples of the timekeeper each point when the client made a request in the past. Yeah, we're gonna unfortunately have to change our name here because this is not criminal information, it's just tracking. This whole information about a client of the web server. So this is morphing more into just general information about a client. Dossier, yeah. We'll just call it client. And we're, instead of calling it band peers, it'll be clients. This holds information about known clients of the server. Okay, and then band peers becomes clients, really. 13 occurrences. And the criminal record becomes client. Oh, I can't use the struct client because that means something already. client dossier. What does dossier mean? The French word. File containing detailed records on a particular person or subject. All right. This needs to be client dossier. There we go. Alrighty. So we don't want to erase them off the list. Actually, we want to keep them going. Well, actually, we can erase them if the oldest request is too old, right? Yeah. Actually, I'm not even going to worry about it. Instead of erasing, we'll just reset the ban period to the initial ban period. So what we'll do is every time there's a new request, where is that? Data received. Yeah, every time there is some kind of request, we will, whether it's good or bad, we will add the time. So that means I'm going to want to get a handle to the client a lot earlier than I am right now. Yeah, so way up here. So client or auto client equals clients connection state connection get peer address like that, and then client dot last request times dot pushback now. Do I have a now already? No, I don't. I like to do that in case I need to use it later. Also, yeah, yeah. Right. So what we can do here, while client dot last request times dot back or front is less than now minus, what's now again? The double, so minus, are we gonna make the window only 1 second long? If I make it 1 second long like that, then we can't have a period less than 1. Yeah, I guess it's reasonable to have the period to be at least 1, right? So yeah, well, let's make this a constant. So too many requests measurement period. up here. This is the period over which the number of client requests is measured. It needs to be at least the 1 over something. Is that called the inverse? No. Oh, I'm so weak in my math terms. What is it called in math when you have 1 over n? 1 over n is called what? Duh. Is it called inverse? Multiplicative inverse. So inverse. The inverse of the yeah, because if it's 10, then it means it has to be at least 1/10 of a second, right? Well, no, hold on. What am I thinking of? It's per second, so yeah. If it's 10 per second, we need to measure it for at least 1/10 of a second, right? We really need to measure longer. That's fine. Maybe we do make it configurable, though. Too many requests. So let's make it configurable. Measurement period. This is the period of time over which the number of requests made by a client is measured. Just copy this. And we'll set it here. Too many requests, measurement period. There and there. Whoa, what happened there? Paste bug. Okay. So by default, it'll measure every second, and if there's more than 10 in the last second, it'll be an error. So too many requests measurement period. Client.last request times .pop front. So it basically pops off timestamps that are older than, like, you know, if this was 1 second, then older than a second ago. And it'll be basically if how many are left is greater than or equal to, does that say greater than? Yeah, greater than too many, right? Too many requests threshold. Then we will, actually, makes me think I need to change my test here. Because it's not that we get banned right away when we connect, it's when we make a request. So this should be an assert false. And this should be an assert false. But we should interpret the response, actually. which means we don't need the client down here, and this can be just that. Yeah, we expect a special HTTP response code. Now what would be a good response code? HTTP response for too many requests. Oh, there we go. There already is one. 429. Okay, so 429 response status code, right? And then we'll expect that it's broken gracefully. Okay. And they'll be banned. It says we could have a retry after. Do we want to put that in our server? I'm kind of thinking no, because it's just giving the hackers some information to tell them when they can hack us again. I'd rather just, like, since it says it might be included, I'm just going to say we're not going to do it. At the third time, expect a little. You're right. We should try to connect and be banned. So try to connect again, but expect to be banned. So that's this little bit of code here. Expect true. Could you please use the proper technical term hacksaw? Sure. I will do that. Hacksaws. We don't want to give the hacksaws any information that they could use against us. All right. This looks good to me. So here, I think what we'll do is make this an else if. We'll make a special response here. So response dot status code is 429. Response dot reason is too many requests. And then do we need to do anything else? Do we want a body? I'm going to say no. Because it's really not meant for a person, it's meant for a hacksaw machine. Oh, but we do want to set the close, don't we? We want this one. All right, let's try that out. Okay, looks like we broke some previous tests. Those previous tests might be doing a lot of requests or something. Connection close or not. Oh, let's just run it in the debugger and see. It's faster that way anyway. Just tell it to go. All right. So we get banned right away. Because go away. Actually, why are we banned here? What's I equal to? 1. That's on the second pass it gets banned. Actually, I'm not sure why. Let's put a breakpoint there and reset. And then go to iteration 1. And then go into that thing. That will go into here, right? Actually, it's going to be, the problem is it's empty. So it's really, I need to be there. And reset. Go, and then I is 1, right? So then it's in the new connection. Something's wrong with the new connection. So go. Wait a minute. They've been... Oh. They're being banned just by having a dossier. That's not good. Okay, we'll just say whether or not they're banned. So bool banned. This flag indicates whether or not the client is currently banned or on probation. Alright, so let's look at where we use ban start. Okay, in either of these places, they're going to be banned, right? Oh, actually, hold on. It's only this. Okay, so this is a little bit different. They're always going to be found, so we might as well do this. Right, so it's if they're already banned. Then we double it. Otherwise, we set it to the initial. And we ban them. Right? So again, I think we're always going to get a reference. And we'll say if they're banned. If client banned, then they're still banned. Otherwise, they are not banned anymore. Could you please use the proper... Oh, sorry. I thought I just heard a chat ding and then you chatted again, but you didn't. I am hearing things. So right, the ban is lifted if they send a new connection and the ban time. They're off probation. Yeah, that looks good to me. Try that. Okay. So what's 2217? 2217. Okay, so we're not getting a response from the second request. Why not? Let's see why not. Is this not a complete request? It looks complete to me. Let's repeat. Oh, actually, oh, I'm missing some code, that's why. We did not call a delegate a second time. We didn't send the second request, that's what happened. Okay, it got further down, 2231. Okay, we weren't banned, like we should have been. Oh, yeah, I didn't do the banning code, did I? We need to ban them. So client.banned equals true. And actually, if they were banned before, we need to double the time. So we should probably take that code that's in issue response and break it out. Oh, I don't need to do that anymore. Yeah. So we'll take this code out here. We'll make another method for it. Where to put it? Where to put it? Parse request. Try request assembly. Start next request. Issue response. Oh, we'll put it here. Void. Ban hammer. And it is connection state, right? Connection state. Really, it's client. Client dossier. Client. Put it here. This method is used to ban a client. It's called to ban a client. So this method bans the given client from the server. Okay. So it's ban hammer client. And then the same thing for the 429. Okay, what happened there? It's still not getting banned? Is ban hammer not correct? Let's see. It's not. Ban hammer wasn't actually banning them. So it should also do that. It means I'll need a now. Move that into here. Okay. Still no. Still not getting banned, huh? Oh, do I have, no, I had the, do I have something backwards? Oh, it's not, is there not getting unbanned? 2 requests particularly so they get banned. Oh, right, I need, that's doubled, so from 0, it'll be 2-second ban. So we need to wait at least 2 seconds before coming in again. Because the ban got doubled. Still banned, huh? Let's see why. So that's there. Go to it and find out what's going on. Server, new connection. Somehow they're getting banned. Ban is being extended. So it's 2.5 seconds now. Oh, I forgot to configure the ban period. That's why. Yeah, I didn't set the ban period. Or the probation period. Actually, it doesn't matter the probation period. It's just the ban period that I care about. Actually, I'm gonna debug that because that should have doubled it. It was at 60, right? It should have been 120. Yeah, it wasn't doubled like it should have been. Oh, while they're banned, okay, it's when they get on probation it's doubled. Okay, so never mind. They're just ignored during that 1 second. It doesn't double their ban. It would double if they did another request too quickly. And I should probably expect it's not a 429 down here, right? Cool. All right. Let's check this in because I think we're done. We're done with the banning and unbanning both bad requests and too frequent requests. All right. So what did we really change here? Okay, so it was previously it would just be any bad request bans you permanently. So what we really did was allow lifting of bans, but also ban for too many requests. Really too frequent requests. Right, on probation. Extend, okay, so we're gonna say make ban time limited and configurable. After a client ban is lifted, the client is initially, the line is put on probation for another time period. While on probation, a client sending a bad request or too many requests will banned again with ban time doubled. After probation period, client ban time is reset. Too many requests in a given time period. Actually, I think I have a bug in how I measure that. Too many requests. Well, I think we need to divide that size by the period, don't we? So really that should be well, let's do it in 2 steps. So the size, we can make it easier to read. So we can say const auto num client requests, right? Across measurement period equals that. But then average client requests per second is the convert that double. Let's convert that to a double and then divide it by the measurement period. And then if that is greater than too many request threshold, too many requests in a given time period will result in a ban, and send 429 response when too many requests threshold is exceeded. All right. I should run the test one more time. Okay, so we're good. We're gonna commit that and push it. Let's run the other test to make sure nothing in the other test framework broke. And then I think I want to build this on Linux and push it to AWS. So, okay. Set up my terminal. So I know the font is terribly small, but I'm not going to really use this terminal. I'm going to run SSH agent, add my key, Then also add, where did I keep it? Maybe I don't have it here. Ah, here we go. SSH add my AWS key, and then XFCE4 terminal. I'm gonna do all my work on the terminal there. Alright, there's me terminal. My Linux terminal. I'll get pull there. And then we'll build for Linux and we'll run the tests and then we'll push it to Amazon Web Services. So build, cmake dot, to make sure we're good, and then build it. And okay, and test it. The tests take a bit of time, don't they? 6 seconds on Linux and 8.5 seconds on Windows. Okay, so now I'm going to stop the server on Amazon Web Services, and I should have done this before. I need to, hold on. You get the host name. Here's the host name, so it's, I remember how to do this. Go to the web server in the build directory. SCP web server to EC2 user at, and then the host name, paste, and then :/home/EC2 user. Alright. And then we should copy the plugins as well. So lstage. Those look up to date. So we're going to SCP plugins star.so to EC2 user at, again, paste, home EC2 user. I think, did I put it there in the plugins directory? I did. Plugins. Okay. And let's run the server. Okay. Ooh. Someone's pinging it. Someone's posting random junk to it. Interesting. Heh. Someone's like posting random PHP scripts to it. It's interesting to see what they're scanning. I don't want to show it on the screen because it'll reveal the IP address, but they're getting a lot of 404s because my web server is like saying nope, 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 nope. I'm wondering if we should ban them by having like a 10-second measurement interval, and if they do more than 10 requests in 10 seconds, then ban them. Oh, they stopped probing me, so actually they either probed it or the web server crashed. No, web server's still going. I'm waiting for MathBot 2000 to ask me a question. I'm guaranteed to win since no one else is playing. Okay, that is 108. Alright, well I'll leave, maybe I'll leave this running. It's interesting, right when I start the server, I immediately got hit. And it did a bunch of interesting trying to post PHP scripts to the server. And then trying to get them back again. So it got my standard feels bad man response for every get. I remember how to do this. Yeah. I'm just looking at the log of requests that they did. Huh. Yeah, it's interesting. Anyway, we seem to be no longer under attack. That guy. Well, let's play around locally with let's see if the banning stuff actually works. So the way I would do this is run it locally. So W stage, and then we're gonna edit the configuration file to put in those new configuration items we had defined. So it was, let me go back to my unit tests and see. Unit tests, where are you? Okay, so we have initial ban period. Right? And I don't know. How about 10 seconds so we can play with it? And then too many requests threshold. Let's say 10. And then the other one is measurement period. Here I think I'll say 10 as well. Okay, let's try that. And then what I'll do is I'll do W serve. So ban period is 10 seconds. I'm not seeing the other print messages though. For too many request threshold, too many request measurement period. Why is that? Oh, probably because the defaults were 10 and 10 already. No, that was 1. I should have seen it go to 10. Oh, maybe I have a bug. Yeah, I do. So, oh no, no, I don't. Yeah, I should have seen this. I should have seen that message. I'm not seeing that. Spell it right? Maybe I didn't spell it right. Looks right to me. Huh. Interesting. Is it not parsing correctly? Hmm. What am I doing wrong here? Let's put a breakpoint here and set this up to run. Properties, debugging, dash C, config.json. I'm not sure what this project directory is. So, okay, so I need to go 2 levels up then. Dot dot slash dot dot slash. All right. Go, my friend. Okay. Why is the value 1? It shouldn't be. Oh, I'm running the unit. I'm running the wrong thing. Duh. Set that to start. Then go. Oh, why is it empty string? Maybe there's a problem with the JSON. So I really need a configuration, and I need object value, and I need server. I need the server's object value. Okay, 2 floating point values. It is 10. Weird. Why is the value an empty string, though? Huh. Very confusing. It's there. Too many request measurement period. Yeah. Very strange. Restart. And I'm gonna go into JSON and look up the operator index. With a key. Yeah, so here. So go. Key server, idle timeout. Server inactivity timeout. Server initial ban period. Server port. Server request timeout. Server, here we go. The entry, it found an entry. Entry second. Floating point. Value 10. Oh, it's converting it to a string? Oh, that's right. I forgot. In my configuration file, I wanted, yeah, my bad. I want these all to be strings. So that floating point value was interpreted as a string, and I don't have float to string conversion. It just returns empty string. Okay, my bad. Let's run this again. Oh, interesting. Look at that. Did I not do that right? Threshold? What am I doing in that code? It would be here, right? Okay, shouldn't say threshold. Oh, okay, yeah, that's LF to LF, right? That as well. Interesting, I didn't see that before. Okay. Everything else looks good, though. Okay. So yeah, so 10 seconds. So now I should, if I hit my own server more than 10 times in 10 seconds, it will ignore me. So what if I just hit no, not. Huh. Server's already down? Huh. That was interesting. My server got hung. I guess I haven't fixed the race condition deadlock, or there's another one I haven't found. Anyway, I didn't mean to go to my main web server. I wanted to go to my local one. I want to hit it more than 10 times and get banned. It's not banning me. I want to be banned. It should have banned me. Yeah, there's something going on because it's not being banned. So let's run it in the debugger. And I'm going to get prepared to set a breakpoint on where that window is checked. So that's in HTTP. Server. And well, it's where this is checked, right? Right here. I'm going to get prepared to set a breakpoint there. Move my cursor around. Do I have any other breakpoints? No. So go. And hit the server a bunch of times. And now I'm going to set the breakpoint and hit it one more time. So 23 requests. The average was 2. Oh, it's per second. Yeah, okay. And then I did I didn't set it up right. It's this per second, so it'll be that times that. In other words, don't let more than 1 per second over a 10-second period. Actually, I guess we should wait and we should have it wait, shouldn't we? How do I want to do this? Yeah, we should probably not do this check until we've done this pop at least once, right? Just thinking how I would do this. Maybe if we just kept a record of the first request. No, that's not quite right. Actually, I think we're already dividing by the period anyway. So we're fine. I don't need to change anything. I just need to set my thresholds a little bit better. So set it to 1. Run the server. And then just hit it more than once in 10 seconds. No. Still I'm not getting banned. Did I not do this right? I didn't set it up right. Did I not save this? Oh, I didn't save it. That would explain it. Okay, so now refresh. There we go. So the moment we hit 10, we got disconnected and now we're banned. And I will stay banned. Actually, we're not printing a message when we get unbanned. What's the ban period? 10 seconds. So as long as I wait 10 seconds and try again. Okay, there's our one. No. It didn't work. Actually, that was more than 10 seconds, so it should have allowed us to connect. So now I want to see. Oh, I think it's stuck. That's why. Okay, so let me see if I can catch that. Actually, what I should have done is just attach the debugger to that. I would have caught the deadlock. So refresh, load a couple times until we're banned. Here's the server window for that. Wait a little bit of time. 10 seconds or so. Oh, actually, we got a 429. Oh, I'm not printing it though. It should show up in the diagnostic log. Okay, it should have been long enough to get unbanned. Oh, was it? Oh, hold on. Was the ban 60 seconds? Might have to wait 60 seconds. Yeah, no, it was 10. So why am I getting rebanned every time again? Let's find out. 429. So right here, if I hit reload one more time, I'm not even getting to there. Okay. Why is that? Oh, I think it's deadlocked. So let's hit pause and see where it is. Let's find the deadlocked. Is this it? No. Okay, this looks like it's deadlocked. I thought I fixed this, so it's all of these are waiting to lock the server. So something has this. Actually, if we look at this mutex, it'll tell us who has it locked. 4140 has it locked. So what is 4140 doing? Closing the network connection? Oh, it ends up with the last reference to it somehow. Oh. Hmm. Okay, yeah, I think I see the problem. We need to clear this this copy at the end while not holding the lock. So yeah, the timer thread ended up having, yeah, so it's like this. When we because we unlocked, it's possible that this active connections might have gotten changed, which it is. And so we might end up having the last reference to a connection. So we need to clear our local copy of our references while not holding the mutex. That's what it is. Probably what's happening on the web server live too. All right, let's try this again. Hit it a couple times. Whoops. Where's my debug? There's my debug window. So we're getting 304, 304, and then, oop, 419s. Or not 419, 429. And I really should have printed out the 429, shouldn't I? Okay, so we got unbanned. We got 200. 304, 304. And we're banned again. We will probably be banned for twice as long now. Yeah, look at that, we're banned. We are banned. I should probably print something to say what the ban period is, right? Okay, so there's two things I want to print. Yeah, it's ruthless. We want it to be ruthless. Okay, we're still banned. I want to see how long we're being banned for, actually. So let's build that into our unit tests. We need to expect a couple things, right? Oh, before I do this though, I should check in that fix I just made. Okay, a couple fixes. These were print formatting issues. So fix print formatting errors. And then the server, this is fix another deadlock. It's possible for the timer thread to end up with the last references to flow to connection objects. So to avoid a deadlock, release the server mutex while releasing connection references. Yeah, I had lunch with a friend yesterday who reminded me about how stupid I am by having so many mutexes, and that I should be using lockless data structures, which I should really put. Actually, I did put it on my list, didn't I? So if he's watching now, he can see, yes, I'm going to refactor this to not require, at least not require them as much, but try not to require mutexes at all. Would be nice. Okay, so we're going to change one of these messages, one of these tests. Probably the first one that has the ban, right? Bad request diagnostic message. Bad request results in ban, yes. Okay, yeah, this is when it gets extended, I want to see a message. Issue a bad request again. So here's where I want to do the diagnostic log checking. I should have put that in the clipboard first. Right here. So right there, I want to see. What do I want to see? Request. Mock client. Ban extended to 2 seconds. And we're also going to see, actually no, it's not going to be extended there, is it? It's down here. Ban extended to 2 seconds. Oh, we'll also get the bad request, right? This one. And that. Where will it be relative to this? It's this ban hammer. So it'll be before the close. Huh. I don't remember this diagnostic message. Okay, well. That's what I want to see, so let's make it happen, shall we? Yeah, that's the right one. So let's print the message now. Let's copy this. Ban hammer. So it'll be that. Oh, request. I'm putting the special request there so I can grep for it later. Ban extended to 12 seconds. Okay, so we need to name. But I forgot to document the argument, didn't I? Param client. This is the dossier of the client to ban. This is the address of the client to ban. Alrighty, so client address goes there, and then client ban period goes there. And then ban hammer needs to be passed 2 arguments now. Client, and then, well, let's cache that. const.o client address equals that. And then use it in both places. Probably need to do the same thing to the other ban hammer. Yeah. Client address. There and there. Bad request. Okay, so this order is slightly different, which is fine. And then I don't want to see the 555 actually. Okay, yeah, I think I needed to set something, right? Bad request report bytes. It's printing more than I need to, that I really care to see. So now it should limit it to 10. Now what's different here? Oh, 2.0000000 seconds? I think the way to fix that, instead of using F, use G, right? And I think when you do that, instead of 2.0, it just says 2. Yeah, alright, so that's good. And then the other thing I wanted, or should I check these in separately? Yeah, let's check it in separately. So this one's about print, this is in server, print diagnostic message when bans are extended. I wanted to see the 429 in the diagnostic messages as well. Okay, this stuff. So looks like one of these, right? Request space, yeah, this kind of thing. So get, I think it's just slash, get slash no body from not client ends in a 429 with no body. And we will clear it right before. So right here. That's the problem right now. It's not going to be printing that, and it should. We're just getting a close. We're not getting the get. So I think it's because I bypassed that code. Yeah, so it's false right now. So let's refactor this out a bit. This long diagnostic message, I want that to be its own method. So void report request, right? And we'll just have it do that. So what does it need? It needs the request. So const request, and it needs the original target as a string. We'll just call that target. So dot in all these places. All right, the original target string is just target. So it needs a it needs a response. So request, a response. And it needs the, okay. It only needs a connection state for the connection, and only that for the address. So we'll just build that in as a peer address and put that here. Okay. This method publishes a diagnostic message about a client request. This is the request from the client with the target possibly modified. That's why we're passing in the target as a separate string. This is the response that was constructed for the request. Target. This is the original target URI rendered as a string. And then peer address. This is the address of the client who sent the request. All right, now to use it. Two places. So one is the original place here. So it's star request, response, and then original target as string, and then this thing, peer ID. Actually, that's not the address, is it? Let me change the name of that. It's the peer ID. This is the identifier, the peer, because it could be, you know, it's a specific browser connection, not the whole browser or the whole computer. Okay, so we're going to call that from the 429 place as well. We will do it right after we set this stuff up. Original. We don't have the original. Oh, okay. So in this case, it's just this. And then the peer, it's the same, I believe. It's just that. All right, let's see if that fixes our test. Cool. All right. So how about in general? Our test suite. Cool. So let's check that in. So this one is fix problem in 429 responses not being logged. And this is in the server again. Commit that and push it. And then we'll do an w stage w serve. And we'll test this a little bit. So reload a bunch of times. I can do it 10 times and then I get banned. I get a 429. And then see here, I got my ban extended to 20 seconds. When I try it again right away. And right now I'm still banned, but my ban isn't being extended. I gotta wait 20 seconds. I didn't quite wait 20 seconds, did I? Let's see, there it finally got through. Because I guess Chrome retried. So at that point we can, oh, got a few more times, but then I got, no, it's still passing. I get past 10 though, again, I'll get banned again. There we go. Got a 429, too many requests. Ooh, my ban's extended to 80. Because I was in the probation period. So actually, this is a good point. I need to take a couple minutes break. When I get back, my ban should be lifted and I should not be doubled again. So I'm going to take a few minutes break. Just a quick break. I'll be right back. I'm back already. That was really quick, wasn't it? So now if I hit refresh, then I can load another 10 times, but when I do get banned, I try again. Oh, oof. Ban is now 160 seconds. Oh, I didn't wait 80. my break wasn't long enough. Okay, fine. That'll give me some time to deploy this, test it on Linux. Let me do that. So we're going over to Linux. There. It was, I'll just pull everything. It was just HTTP, I think I changed. Yep. So build it, and then we'll be testing after we build, and then we'll be deploying it. Test. All right, so I'm going to deploy. So yeah, let's stage. That's only one directory up. Stage. And then, yeah, actually I should be in this directory, shouldn't I, for this SCP to work. I probably don't need to copy the plugins again. But I'll do it, why not? And that's interesting. While I was pushing that, my stream started to drop. I guess that makes sense. My copy is exceeding that, plus my streaming bandwidth is probably hitting my upload limit. Okay. So, my web server, I think I'm going to set those extra options up. Let's set that up here. Bark, bark. I don't know who she's barking at, but let me mute it for a while. Okay, I did not hear it, but my dog did. Someone delivered a package. This is why you should always get a dog if you don't have one. They tell you when someone delivers a package, even if they're super quiet about it. So I think what I want to do is grab my configuration off of the server. Copy, paste. Home, EC2 user, config, JSON, then we'll edit it. Yeah, this guy. So what are we gonna set here? This doesn't look right. Oh, I know why, because I put it here. No, build. Ended up putting under build web server there. All right, so let's set up those other new keys. These ones. So what do we want to set? Okay, copy. Paste, there we go. Initial ban period. I don't know. A minute. Too many requests. So let's say that let's say if they do more than basically 0.5 over 10. So over 10 second. Well, I guess a better way would be say 1.0 over 5 seconds. So if they do more than a request, actually I want to reduce that again, but then increase this. So if over a 10-second period they do more than one request every 2 seconds, then they will get banned. Because what I was seeing from the whatever was probing the real server is it was sending it every second. So this will get it banned after 10 seconds. Is that right? Yeah, when it gets up to 5 requests within a 10-second period, right? Thinking, is that too aggressive? Maybe we'll increase it to 20 seconds. Let's try that. So we'll SCP it back. And we will run it. Okay, so I didn't get banned by connecting by myself, which is good. If I do this too much, I'll end up banning myself. I got banned. I banned myself off my own server. But it should be okay as long as I wait like 10 seconds, right? We try now. Oh, still banned. Oh no, I set it to 60 seconds. Yeah, I've been banned for 60 seconds, haven't I? Oh, maybe a good thing. Good thing to ban them for a whole minute. And they'll probably not try again. I guess for that minute. Oh, this is probably long expired now. I can go back here and hit reload. Yep, and then if I get banned here, it should just default back to 20 seconds. Yeah. All right, so we're good. All right, so I'm not banned anymore. The other thing is once you have a WebSocket connection, it no longer counts as a connection. So we should probably put more security on the WebSocket itself. Like, well, we already sort of do because MathBot 2000 ignores you if you if you answer more than like. See how it's only taking my answer every couple of seconds. So it's already kind of rate limited there. And I managed to lose 5 points doing that little experiment. Anyway, I guess we're good for now for the blacklist, which means I can maybe do a little bit more than I plan to do, because I can go until 2. So let's see. Last time I had a bunch of stuff I wanted to get to, I never did. So on the original plan yesterday, I'm kind of at this point because I just did this much. So the next thing I was going to do was have multiple spaces in the static content plugin. That's so I can do things like get rid of the, what is it? The fact that I'm going to static/index, I'd like it to just go to like a chatter index or something like that, or just chatter. Actually, the turning that into that would be maybe another plugin's job, or maybe something else for the static content plugin, right? So right now it won't do that. Actually, what does it do if I go to that? It just says it's not found. Actually, what happens if I do this? Oh, that's not cool. All right, I need to fix that. Because I can do this, right? For example, ../../. Oh, okay. It's not. I was thinking it would go back. Yeah, okay. It's resolving it like it should. So I didn't want it to allow you to like go up the tree far, but it's actually okay the way it is. Yeah, it's turning into a /abc get. It doesn't go. It doesn't go to the static content plugin and then take a path that leads above the root. What I was afraid it might do, because then you could reach back into system files, right? It's not doing that, so we're fine there. Yeah, so I wanted to do something like have it go to just chat, right? Actually, chat is the WebSocket's address, but like if like chatter or something, or maybe math would go to the math quiz room, but then if you went to just /, it would go to another space, right? So it doesn't do that yet. Actually, do I allow overlapping spaces? I forget now. Let me look it up. I don't think I do. So let me check. That would be in our unit tests. Let me collapse everything. Do I mention overlap? Do not allow overlapping subspaces. Okay, so I don't allow it. So if we register foobar and tend to foo, it should not be allowed. It would overlap foobar. Okay. So yeah, I wouldn't want to then have something like at the /. Actually, that is a problem though. We kind of do want to allow subspaces, don't we? Or we want some overlap because we want the root of the website to go to maybe a static page and then /chat room to go to the actual chat room. So how would I handle that? I guess I'd have to change my use case here and allow overlapping subspaces. Let me put that down as something to do later, because that's too much to do now. Let's see, allow overlapping resource subspaces. This is in the server. Example use case. Slash might go to the static content plugin, while slash chat goes to a special chat room, while API goes to some RESTful plugin. Right? So we want to support that. So to do that, we'll hold off on doing that today. Maybe we'll look into the chat room right now. So switching gears to React for a little bit. So I was seeing some warnings. I wanted to look into that. So let me keep the web server going. And we'll open another shell. And we'll go to the chatter and do npm, is it build? Actually, start will show us the build warnings too. Then we can take a look at those. Oh, and I should probably make sure I did not accidentally change anything else. Same thing on the Linux side, actually. I think I did change something else there. I had a local copy of the config file, right? Oh, it's ignored because it's in the build folder. This had a change, though. Right, so I did that temporarily, just to play around. Yeah, we'll stop that guy. We'll get reset. And then we'll start him again. Okay, so here are the warnings I'm seeing. So we have a not equals on line 14. Take a look. Not this one. This one. Chatter. You can close that. Chatter source app.js line 14. Ah, yeah. So I'm used to doing that in C++. I need to get used to doing it like that in JavaScript. And 78. I have another one. And then 158. That's another one of those things. Yep. Okay, and then we have a bunch of warnings about redundant blocks. This one I'm not sure what to do because I have these blocks here so that I can do stuff like this where I have a variable that I want to have scoped. And it doesn't warn me about these being redundant, but it's warning me about these. I want to have them in all cases to be consistent. So I'm wondering, what do I do about this? It says I can add ESLint disable next line. Maybe that's what I want to do. So it says I can, what do I want to do? Select that and then paste here, I guess. On 127. Paste. Okay, and then 138. So for now we'll do that until I learn about a better way to do it. I hate doing that though. Let me put that on my notebook as a research thing. Research, topics to be researched at some point. These aren't necessarily in order, although I have been doing them in order. Actually, probably what I'll do is have these. Yeah, I might do them out of order, but I'll try to keep the order here in the same order as there. So, learn more about the what's considered best practice for switch case in JavaScript regarding extra blocks and local variables inside of a case. Alright, so I'll research that later. So we were down to one warning, line 319, available nicknames is assigned value but never used. Is that so? 319. Huh. Oh, I sorted them and I intended to use the sorted list but never did. Interesting. It was supposed to do that. Okay. And no one ever noticed that, I guess. So that's localhost 3030. Why didn't that work? Oh, 30,000, not 3030. Right. And then this should be 8080. Okay, so they're, yeah, of course they started out in order. I can't really see if their order will be changed, but I could see it in the original app. They are not in alphabetical order, correct? Actually, they are. No, they're. Oh yeah, they are. But that's just because they were in the config file, I think. No, they're not. So they got sorted. So how did it get sorted here? Nickname select options. That somehow sorted it even before I did the sorting. I can show you guys the config file on the server. Gremlin's last, but here it's not last. Somehow it got sorted. Even though I haven't deployed that to the server, this change here, it should be doing that. Oh, does sort modify the argument? It doesn't, does it? So how did it get sorted? Oh, maybe the server is sorting it. If the server sorts it, we don't need this, do we? Oh, wait a minute. I think we need it because, yeah, I can maybe demonstrate that. If we grab Bob, for example, and then we become a lurker again, it would not end up in the correct place if I used this version of the app. Try that. Did I get banned from my own server again? What happened? Uh-oh. What's going on? Oh, whenever I reload it, I need to put 8080 there. Alright, so I take Bob, and then I don't take Bob again. Oh no, it's still sorting it. Okay, I don't know why it's how it's getting sorted. Oh, what is it? Unless this is modifying this state available nickname somehow. I comment that out completely. Connect. Oh, I have to say 8080 again. Right, Bob. I think that is the case. That mutates, which is bad. We shouldn't be mutating that. Let me confirm that. So we're gonna look it up. So JavaScript array.sort mutate. How can you sort it without mutating? Yeah, just copy the array. All right, doing the spread operator before we call sort. Okay. Like this. Yeah, we don't want to mutate anything in the state. So let's confirm that this did not mutate the original list. So yeah, it's not sorting it. So to sort it again, we change it back to using the available nicknames. Connect. There we go. So now we fixed the warning message, and the warning message actually keyed us into a bug that we had. That's good. So let's go check that in. So here's the bug that we had. So fix, this is in chatter. Fix compiler warnings, and then one warning. One warning was a clue that that led to the discovery that the state was being mutated during rendering. Prevent the state mutation by making a copy of the state before changing beforehand. Alright. So this is why you should always look at your compiler warnings and resolve them one way or another. So what's next? Got like 8 minutes, so we're like probably count. This one I'm not sure how to do yet, so I'm gonna skip that one for now. Timestamps of all tells. We can do that, right? So that's a server mod plus a client mod. Let's do the server mod first. So let's clear our workspace here. In the server, there's going to be a test for the server. Chat room plugin test, right? We want to see a timestamp on every tell, basically. So we'll look at tell. Right, so this is going to be tricky because the timestamp is based off of our timekeeper, right? So we can set whatever time we want. Awesome. Yeah, so I'm going to take advantage of that. So wherever we have a tell, we're going to want to see a timestamp. So Alice says something at, I don't know, 2.5 seconds. So we will expect an extra option here, timestamp. We'll just say time, and we'll say 000002.500. We'll do it to the millisecond. Hours, minutes, yeah, okay. And we need to make the timekeeper. Where do we get the timekeeper? Server.timekeeper. Server.timekeeper. Current time is 2.5. Alright. So, tells. Okay, so we have to set a time here for this tell. We have to say something. We'll just say 0 because we have not set the timekeeper on that. Tell from lurker says something. Okay, so again, it'll be 0 because we haven't moved the clock. Okay, so we'll simulate this a little bit. So server timekeeper current time. Let's say it's Bob answers it at 1.5. Alice is a little too late, right? So we'll expect 1.5 for Bob, and then we'll expect a 1.6 from Alice. Okay. Right, so it's advanced by 1 there. So it'll be Bob tries at 0, gets a penalty. We should advance it a little here, right? What's the... Okay, 1 and 0.1, I guess. Let's just say it's equal so we don't have to worry about what it was before. One, and then 1.1. Okay. Actually, the MathBot tells should have a timestamp as well. Right, so this will be at 11 seconds, right? Oh, we had it configured for exactly at 10 seconds. And then Bob tells at 11, right? Actually, we expect it right at that time. Yeah, okay. Alright, so we're good. So this is going to fail all of our tests at first. Web server, chat room plugin, debug, chat room plugin, tests. All of our tests that had tells in them are going to fail because there's no timestamp. Let's add the timestamp now. In the chat room plugin. This will be the last thing I work on too, because I'm going to wrap it up after this. We're tell. Actually pretty simple. So all we need to say when we post a tell. Okay, we should refactor this out so there's only one function that sends tells. We have it in 2 places because MathBot 2000 has its own special tell. So it'll be in 2 places for a little bit. So yeah, let's make a function right away that make a timestamp. So format timestamp and then time. We have a timekeeper. We have a server. Okay, we have a server. Get timekeeper. Yes, we get current time. There we go. So we want this kind of a thing for every tell. That handles tell messages. Yes. So it goes there. So we need this format timestamp function. So that can be in the anonymous global namespace. We will make it a return a string, and it will take in double. Okay, this function formats the given timestamp. Will renders given timestamp. I should probably call it render timestamp, shouldn't I? Into the format to be displayed by to users. Actually, now that I think about it, we ought to do this in JavaScript, but I'm gonna do it in the server side for now. Timestamp. This is the timestamp to render. Return the given timestamp rendered into the format to be displayed to users is returned. All right. Okay, sprintf. So it's going to be %o2 u or d, %o2d, %o2d dot %o3d, right? And so the four components, let me make sure I'm, yeah, okay. Four components are timestamp divided by 3600 and then truncated. So that's an int result of floor. Right? And then, well, let's actually compute it out here. So double or const auto hours equals that without the int part. Then minutes. We'll say timestamp minus equals hours times that. And then minutes is that divided by 60. And then seconds is just the floor of the timestamp. And const auto milliseconds equals timestamp minus seconds times 1,000 and the floor of that. Okay, so it's really just int hours, int minutes, int seconds, int milliseconds. Right? Let's try this. Okay, we have one failed test on 1207. 1207. Oh, okay, so Bob tried to send another tell. A second later, right. So we need to change this. So expected response. I guess we'll change what the expected response is here. Because it's now a second later. Okay, there we go. And just for good measure, while I'm checking in, I'll run the test again. So this was here, which is the root right now. No, it's not the root. It's in web server. Okay, yes. So we add time. This is chat room plugin. Add timestamps to all tells. Okay, and then we push that. All right, now let's do the client side, and then we'll wrap up. So client side, we will get an extra thing in the tells, right? So how do we want to print that? let's see where we do the printing of tells. There we go. Render tell is where we do it. Okay. If there's a sender, do sender colon tell. Otherwise, just say the tell. But in front, we'll put the timestamp. So tell dot. Why is this lowercase s? Oh, okay. So never mind. I see why. The time. Let's put that in brackets, shall we? And then we'll just, wherever we assemble the tell, time is message.time, right? Let's try that out. So, connect. Oh, I'm not running the server. That would explain why it's not running. So, wserve, stage and then serve. Connect. Bob. Alright, so the timestamp is way long. 85 hours, 4 minutes, 51 seconds. It's advancing correctly though, at least. I think what it is our timekeeper does not start at 0. Yeah, so let's fix that. I believe that's as simple as how our web server implements the timekeeper. Timekeeper.cpp here. Yeah, so right now, it just gets the time from the system abstractions, the OS's notion of time. So let's do this. So we'll say static double start time equals impl time.getTime. So the first time it's called, it'll get the start time. And then from then on, we'll subtract the start time. So like we learned in a previous stream, making it static, it's still a local variable in how it's used, but it's actually global and hidden away within the scope of this method. And this assignment only happens the first time the function is called. So stage and serve. And connect. And now when we say something, see now it's based off of how long the server's been running. I suppose we could, instead of counting from the server start, we could count from the current day. And I guess it would be whatever time zone we're in, right? I'm inclined to, right now, just make it relative to the server start. Yeah, we'll keep it like that. We'll change it later, depending on what people tell me. Let's go check that in, and we'll wrap it up. Okay, check this in. So, timekeeper, web server. This is not the web server. Was it? Oh, yeah, it was. Web server. Well, web server is the repo, so timekeeper. A report times relative to the first sample. And push that. Right, from the root, I'll need to check in the changes I made to chatter. There really wasn't much. We're just printing that extra time argument. So chatter, print, tell timestamps. And push that. Hey NetZane, if you do timestamps on the client side, won't the time be local to the user? Executing JavaScript from there, yeah. So it's probably a better idea to do it on the client side. as in the formatting, right? I want to keep the generation of the timestamp on the server side so it's consistent across multiple users. They all see the same times. But we could do the formatting, like turning it into a local time on the client side. I don't want to do that today though. We'll maybe do that next time. So let me write that down. Move chat timestamp formatting client side to account for local time zones. Which means we have to make the server timestamps relative to, I don't know, common base like UTC or something, rather than server start time. Yeah. I didn't want to get into the JavaScript formatting stuff since I'm not used to that yet, and I needed to wrap up pretty quickly. So we'll do that next time, or sometime soon. All right. Changes all checked in. I'm going to go to the Linux side and pull them, build them, and then deploy them onto the server. Let's just see, is the server still running? Is it still running? Ah. Interesting. I'm being ignored by the server. Oh, because I'm a lurker. Duh. So dumb today. There we go. Okay, so it was still running. Let's build. And after it builds, I'll test it and then we'll deploy it. So server's offline. Copy the web server over. Oh. I guess we have to be in the web server directory for that, don't we? And then I'm going to do lstage so that I can then copy all the plugins. Just to be safe. I really only changed the chat room plugin, but just in case I did change something, comment all three, I don't blow things up. Okay, so starting it up again. Actually here, you'll see that initially you won't see timestamps and you have to do shift reload. And now we'll see timestamps. And why don't I? Oh, because I haven't posted I didn't copy the client over. So that is in the Windows side, right? I have to do npm run build and then copy that over. Yeah. Forgot about that. So I put it all under chatter. So this will be like an rsync, right? I should use rsync instead of scp over there too. So it put it under build. Right, so I want to do an rsync. Oh, I always forget this. What is it? I don't remember what the command was. Have it in my personal notebook. Oh, I do have it. Okay. Need to copy this over to the Excalibur notebook. Rave. This is. Yeah, so it's star to EC2 user at this address /chatter. Oh, that's not right. Oh, and I forgot to do a SSH add anyway. AWS first. It likes backslashes, doesn't it? No. Oh, because I'm in the wrong shell anyway. I can't remember if I added the key here or not. Okay, so this was in chatter build, right? So this command. Almost, but I had that path wrong. Home EC2 user chatter. Fatal error. Oh, it didn't like. It doesn't like. Okay, installed rsync. Yeah. Okay. Fine. I need to. I'll fix that offline. That's a bug in my Sigwin setup. Need to fix rsync in my min gw git shell. Some issue with Sigwin. Yeah, rsync doesn't come with min gw git, so I tried to get it from Sigwin. It'll probably work here. It's just that it's not gonna know about my key. So what if it's like, if I do this though, home EC2 user chatter, and then I put, is it like SSH D? Need to look this up. Need to look it up. So rsync SSH specify key. -I, okay, -I. What is it called? First -key -pair. Not accessible? Oh, 3 directories levels up. Permission denied. Oh. Okay, I thought I did this. Try again. Bad permissions. I just changed it though. Okay. I'm just going to copy it to Linux and then rsync it from there. Actually, what happens if do I have npm on Linux? Might. No, but I can install it. Oh, it's gonna install a lot of crap. Let's do that later. Yeah, instead I'm just going to copy it over between my 2 computers. So to do that, well, actually, what is there? A. Yeah. Right. Okay. So just copying that directory over. Build chatter build. To this objects. Okay, let's make a chatter, make build, cd build, so it's going to end up here momentarily. There we go. So this command rsync rave ssh star to there. There we go. That was much more painful than it should have been. Now reload. Connect. Oh, I guess I forgot the timestamp for the server answering. It should probably say MathBot 2000 is chatting, right? Anyway, the timestamps are up there. Let me make a note to fix. Actually, when I refactor the tell responses, I'll fix that. So, refactor tell responses tell messages from server. So they go through one function. Also, while I'm at it, have the award. Oh, wait a minute. The award penalty is not a tell. Let's say that. So yeah. So fold award and penalty messages into tell. Actually, these are capitalized. Adding a color parameter. So these messages can also show timestamps. Yeah, so we'll do that. We'll do that some other time. So I'm going to wrap up. And I just realized I put these in the wrong log. So let me move these. These should go here. Okay, so today I fixed a deadlock. Actually, I fixed two different deadlocks in my web server caused by two different threads holding two different mutexes and getting them in the wrong. One of them getting them in the wrong order, or basically trying to get the second one without unlocking its first. So we fixed those two cases. Those are in the timer thread, the culprit there. And then I worked a while on banning for temporary periods clients that either send us bad requests or too many requests over a certain period of time. And we have the concept of a ban list or a blacklist, and it's temporary, and you get out of it by waiting. And then as long as you send a good request and you don't spam too quickly, you can get out of the probationary period and back into good standing. Otherwise, your ban or timeout period is doubled, and that's to prevent spamming, to prevent probes and hack attacks. Not to prevent them, but to discourage them by basically ignoring connections that start to become abusive. So we'll see how that goes. I'm going to watch the log while I let this run over the next week or so to see how that goes. And I got in a little bit of the plan from Monday, which was some chat room enhancements. So I fixed some of the build warnings, and I added timestamps to all the tells. So probably next time we'll either work on more on the chat room stuff or some of these things, like allowing overlapping resource spaces, and fixing up the chat timestamps so that they're formatted in the JavaScript side, and doing some of this refactoring here. That'll probably be enough for next time. So I ended up doing more than just HTTP, didn't I? So we also worked on the chatter program and also the chat room plugin. So I hope you enjoyed the stream today, and we'll go host someone else. Let's see who is on. Well, I kind of want to host Adam again because he had a real rough time this week. He couldn't stream the last 2 days because his internet connection on Fritz. But he's back today, so I think we'll go host him. So anyway, thanks for watching. I will move us over to Adam if you don't mind. See you tomorrow.